Just to follow up, Amir. So when did you get exposed to Python? And this is my first question. The second question is like, did you get any specific training at the company that you did not know before, technical wise,
Good question.
but you just learned when you were in Databricks?
Yes, good question. So one thing that I learned in Databricks, actually, I did not know Spark. The company was really spent, I would say 2 months. First 2 months I started, they really heavily invested on me. So I learned Spark. So it means that I learned how to do all of this machine learning and so on in scale, in a big data, and use this platform. So really thankful to Databricks. And but I was pretty familiar and comfortable with machine learning concepts. Going back to your first question, that about the programming languages, I learned Python actually I was introduced to Python in 2013. Do you remember? It was sometimes that I probably was not showing up for Kristen Morris or advisors meetings. So it was one of those times probably I was involved in like talking to computer scientists or going to computer science courses to learn more about Python. And that was a combination of talking to people and probably 70% me myself just learning about those languages, because I believe if you learn one of them, if you know C++, if you know Java, if you know C even, it's really easy to go from one language to another. It's just the syntax changes, but the concepts and things stay there.
Hi. So has there been any like aspect or skill you discovered like during any of your like different data science positions that like really took you by surprise? Like you weren't expecting to have to like know or do that?
Oh, I see. Yeah, you know, actually there are some expectation if you're starting as a junior data scientist, and the expectation is not gonna be the same as someone that has 5 years experience. So one thing I always ask people to not write on resume the things that they do not know. So that's a huge red flag. So when I talk to people and they say that they know this, and it's not that I want to put them on spotlight, but I really want to know what they have done about specific skill set, and they get stuck because probably they haven't worked on it. So I would say avoid that part. But in terms of skill set that I would look for junior data scientists is that, again, be comfortable with specific, at least not all the algorithms, don't have time to learn all of the algorithms, like basic one. And I can send you the list and I can name it here as well, like decision tree, random forest, linear regression, logistic regressions, like all of these, like these 4, understand them from front to back. So it's like understand what's happening inside. I know you guys are smart, you can pick it up and just apply it in Python. It takes like 5 minutes or even less, 4 minutes to just import a library and apply it. But what is important for me that if you understand that. So understanding it for me, it matters.
Not necessarily like what skill set you need to have going in, but like when, for any of your positions, if there was something you weren't necessarily expecting as like a responsibility or something you needed to know, I guess.
Oh,
if that makes sense.
Me personally, that's what you're asking.
Yeah.
Oh, I see. Yeah. No and yes. Because when I was working at American Airlines, my previous job, I didn't know that much that the communication skill is going to be that important. I knew I was going to do a lot of data science and algorithm approach, but when I entered, I understood that I had a lot of meetings, you had to meet a lot of people, a lot of stakeholders, a lot of people to convince. So these are the things that I kind of was surprised in the first few months, I would say. And that's the hardest part at least for me, and I have seen other data scientists as well, to move from that, okay, you're sitting in your cube, you're programming or writing your homework and so on, or doing all of these things, to actually communicate what you're achieving or convincing other people. I think that was a big surprise for me. And the things that I had to learn to actually improve in my job.
Awesome, thank you.
Yeah, thank you.
And I had another question. What would be the best, in your opinion, the best piece of advice you've received for your career?
That's a tough question. I've received many advice. My mom and my dad give me advice every single day, still now. But okay, hold on. So the best one for my career, the advice I received. Okay, just give me like 5 seconds. I think the best advice, maybe, can tell you the best thing that motivated me to come here, like to actually change the subject. I think that's a good one. I think my supervisor was really, really helpful, Kristen Morris. Shout out to her. So if you work with her, she's one of those people that you actually meet for 5 minutes and she expects you to get a lot of things done yourself. And that helped me, that actually pushed me to be more independent and actually go learn about other things, go learn about other aspects and become more self-independent in terms of research. And that actually really, really helped me and motivated me to get to finance or get to do something else beside doing math. So that's what I would say, that's my motivation. Advice, I don't know. I should think about it. Still, I don't know the best advice.
Okay, thank you. That answered my question. Does anyone? Oh, okay.
So if you have, obviously you have a bunch of different models for like classification, what metrics do you use to choose between which model would be best for a certain scenario?
Good question. So the question I can actually decompose it to two questions. One of them is first of all, how do you measure a model in the first place, right? That's the first important thing. And that comes from the business objectives. For example, for some people, accuracy matters. For some problems, you should not look at the accuracy. Example, if you want to detect cancer, and if you just blindly say, no, this person doesn't have cancer, you're probably 95% right or 99% right, because 99% of the people don't get cancer, right? So accuracy cannot be a good measure here. It depends on the problem, but if you know what the metric is, let's say your metric is accuracy, you have done analysis and you want to go with accuracy, then you can actually put this model right beside each other, really, and say which one has the better accuracy for classification, and then pick the one that has better accuracy, that matches your criteria. But one thing, again, I'm not going to go too deep. You want to measure them based on the data set that they have not seen, not those that they have been trained on. Let's say I've used, right now in my model, in my demo, I use some data set to train my model, right? I don't want to use the same data set to compare my models to each other. So probably I'm going to use some kind of other data set, validation or test data set to benchmark this model beside each other. To answer solidly your question, depends on the problem. Maybe use accuracy, precision, recall, or a bunch of metrics there. Again, depends on this case.
If you were using say cross-validation, I guess if you had k-fold, say you had 8-fold cross-validation, and you got an accuracy, and you wanted to compare accuracy, should you be using the same random state starting seed for those across each model?
That's what you want to do. Yes, that's what you want to do. You don't want to, because if you don't do random seed, if you use different random seed, your training and test data in the first place is going to be different. You want to make sure all the data you want to do apple-to-apple comparison. So you want to make sure all the data is trained on the same data set, on the same observation, and test on the same observation. Because you want to make sure that this is as controlled as possible. Yeah.
And then if you used a different seed, you might get different results based on what you choose.
That is correct, yes.
Should you run a bunch of those with different seeds?
You don't use what we do. If you notice, we set the seed from the beginning. So as soon as you set the seed, everything is reproducible. So that's the best practice. All the data scientist needs to do is that make sure that you can reproduce this result. You don't want to get different results every time you run the program.
Gotcha. Awesome. Thank you.
You're welcome.
I had another question. So what out of all the mistakes you've made in your career has given you the biggest lesson to learn from?
In my careers or in life?
Career.
Okay, what is the biggest mistake? You guys ask tough questions. I didn't expect that. Okay, toughest questions that I've learned. Toughest mistake, sorry. Toughest mistake that I have made. Well, you know what? I think toughest mistake was going back when I started chemical engineering. I should have done, okay, this is not career-wise, but I'm going to talk about both careers and personal. Probably, I really wanted to do math. For many reasons, I did engineering because back where I'm coming from, engineering plays a huge role. Not science that much. Just everyone wants to do electrical engineering, everyone wants to do mechanical engineering, and so on. So I probably would pick what I really liked that time. I wouldn't say passion, but what I would pick that time would be math. So probably that's a mistake. And then later on in life, I came back to it, but maybe it was many years after, like 10 years after that. So in terms of career-wise, well, one thing I can share, because I know you guys are recording, probably I would change, I have had a couple jobs, but I would change one of them or two of them earlier in advance. I would take that risk of going from and actually trying other things before staying in a company. And that's not doing that, in my opinion, not doing that, it kind of closed down a lot of windows in terms of a lot of opportunities, because we are young and you want to try different things. I would say that's a mistake. But yeah, at the end, it worked out well, but I would say that not taking enough risk, that would be one of them.
Okay, thank you.
Yeah, you're welcome.
So another question, when I was in the job market, people were asking me those questions. So where do you see yourself after 5 years?
Yes, that's a very good question. You know, in 5 years from now, I see actually more leadership role, probably in 5 years. So right now I'm very hands-on. So I consult with clients. I travel to client side. I'm probably seeing myself more as having a team of those people that actually deliver these solutions, that are actually doing it. And I'm becoming more hands-on. And hopefully, we will see how it goes. I have some ideas about like setting visions and all of those things for like data science projects and even data science organization in general. Hopefully I get to implement those visions at some point.
We're going to get one more question, whoever,
Sure.
And then I think we should be done because it's 5 o'clock here.
Okay,
So,
yeah.
one last question. Here we go. Who wants to ask? Whoever, just take the mic. All right, go.
All right, so I know you studied some finance before, but like in general, how much business or finance knowledge would you say a data scientist should have, if any, at all?
Not at all, I would say. If I want to just put it in a blanket statement, not at all. The reason that helped me, because in finance courses, a lot of things are time series. Like you have observation of stock prices in time, observation of different things in time. A lot of those are time-based, and time component plays an important role in a lot of business problems. So that's why I'm saying that not necessarily the finance pieces of it, but understanding those time series modeling, bunch of those things that come from finance, that helped me to actually improve in other parts. Because data scientists, you can just break it down. Like you have a bunch of machine learning that they don't have a temporal component, and then you have a lot of machine learning called time series that you have time components. So I think that helped me to improve in that part as well. But in terms of finance, you really don't need to know finance unless you want to get into it. If you want to get into it, of course, it's really, really good to know it.
Okay, thank you very much.
Yeah.
All right, I think it looks like, yeah, we're hitting 5 o'clock. So that was one of the best talks, I would say. Thank you very much. I mean, perfect talk.
I hope you guys enjoyed it. Yeah, I know. I can share the slides with you guys. And if you have question, ask and have my email, and I can send you, if you want to get into this field. This is really exciting field that you can get to. And believe it or not, I'm looking for math people myself, but I'm just looking for people that are really, really good in math and really, really understand the math behind it and have a computer skills. That's really, really, as much as you think.
Is that a job opportunity?
Yes, there's job opportunities. Yes, there are job opportunities. We're constantly hiring as well. So if you have that skill, if you're interested, you're hiring, go to Databricks/career. It's right there as well. If you have any other questions, please let me know. I would be happy.
Is that okay? Is that okay for this crowd to add you on LinkedIn?
Yes, definitely. Go ahead and add me on LinkedIn and shoot me any questions you have. If you're,
awesome.
I'm always advocating for data science, and it's gonna be big in the US for at least next decade, because we have shortage of really, really good people, and that's a good market to get into.
All right. Well, on behalf of SIAM Student Chapter, thank you again for joining us. I'll see you probably in the near future.
Yes, thanks for having me. Thanks a lot.
All right.
Yeah, bye-bye.